Okay, we're going to head into let's do like a brief section out of chapter 8, and then we're going to move into chapter 9, which is matrices. The one good thing is you've seen this before. Okay, you had this a little bit last year with the matrices, and also with solving what we're going to do here, 3x3 system, 3 variables. Okay, so that's a nice thing, at least to finish on. Something at least you have a little bit of experience with. We will have a test over this. I'm not sure if we're going to have a quiz. We'll see how things work out. Seniors, time's winding down. I know you're disappointed.
Yeah, disappointed is the right word.
This, I'm sure you are. But you have your senior walk, next Friday? And then after that, you basically get your finals. So we're going to have to probably get that test in before that. So we'll see where we're at. Juniors, you will take your test at the normal exam time. You will not take it early with the seniors. Seniors will take theirs. And I will have to meet with each senior, and you have to let me know because it takes 2 periods. Okay, so it does take 2 periods. So we have to find a free period either that day or something. And then we got time to figure that out. All right, we are hitting system of linear equations in 3 variables. This is not on your guided notes, but just you got to know how to solve a 2x2 system. So take a look at that one if you would. It's not on your notes.
Oh.
Nate, you remember?
You have to solve for y and then plug in it would be negative 3x plus 10.
All right, so you can solve for y. What's that called? Substitution. And I think there's an easier way to solve this one. Elimination. What can I do right off the bat? Yeah, if you take a look, the y's cancel because if I add these together, I can get 5x equals what? 35. I get x equals 7. Then how do I find the other one? Plug it in, and then what is 5x? Yeah, what if x is 7? 2 times 7 is 14 minus y equals 25. Negative y equals 11. Y equals negative 11 for that one. Or we can do like Nate said. I can solve for y, substitute it in. Either way works. All right, what are all the options that can happen when you're solving for a 2x2? What are all the different things that can happen? You can get a single solution, which means that those lines cross somewhere. Each of those can be represented by a line that cross somewhere. We get one solution. How can I get no solution? Lines are parallel. Lines are parallel. And so you get parallel lines, you get no solution. And Matt, you know the third case?
On top of each other.
Yep, they're called coinciding. And then how many solutions we get for that? Yep, we get infinite solutions. So here, so we get infinite solutions. Now with 3x3, we will have those 3 cases. You'll have one solution, you'll have no solution, you'll have infinite solutions, but we got different formats for that. It won't look the same. Okay. But one thing I want you to at least understand, what in the heck does it look like? Okay, what does the graph of x plus y plus z equals 4 look like? That is a system of 3, as an equation with 3 variables. Okay, you can come up with the answers and plug those in. So here and this is a 3x3 grid. Okay, it's 3-dimensional. Okay, so let me pull this up. Hold on a second, maybe. There we go. Okay. Got my little 3D calculator here. Everybody should carry one. And I'm going to graph that equation. What was it? X plus y plus z equals 4. So I got x plus y plus, whoa, I don't want it there. Right there. X plus y plus z equals 4. All right, now right now you don't really see anything because of the angle. But if you look and I turn it, this would be your answer right there. It is not a line, it is a plane. Okay, it's like a sheet of paper. Okay, that covers that 3 dimensions. And you just kind of get an idea. Now, some of the solutions are 0, 0, 4, like z equals 4, or x could equal 4, or y could equal 4. But no matter how you look at it, it's going to have that. You're going to get that sheet of paper that goes through there. So we're going to take a look at systems that have like 3 of those. So you basically have 3 planes all in the same system. And let's see if I can rotate that up a little bit. And then you can kind of see where it goes through the floor there as well. So that is how a 3x3 graph looks. Okay. All right, now the first thing we kind of always do is, you've done this forever. How do you determine, now this is on your notes, how do you determine whether something's a solution to the system? What do? You don't even need to solve it. Plug them in. Okay, so plug in those 3 points. That's right in the top. Does it work for all 3 of them? So if you want to split the work and try 1 or 2 or whatever, but it shouldn't take much. All you're doing is plug them in, see if it works. And it's got to work for all 3. And sometimes you got to watch. It'll work for the first 2, and you're just going to say, hey, it's going to work for the last one. Don't do that. Don't be that guy. So 5 times 2 plus 3 times negative 1 minus 2 times 3, and I get what? 10 minus 3 minus 6. I get 1. So it works for the first one. If I plug in 2 here, minus negative 1 plus 3. 2 plus 1 is 3. 3 plus 3 is 6. Works there. And then I got 2 times 2 plus 2 times negative 1 minus, what is z again? 3. I get 4 minus 2 minus 3. I get negative 1. All right, so what can you tell me about that order triple? They call it order triple. Is it a solution? Yep, it's a solution. Now, since these are all planes, each of those are a plane, you kind of see there on your notes, we get different things that can happen. The 3 planes can intersect at a single point. That is going to be your one solution. Okay, that can happen. The 3 planes can intersect in a line. You can have infinitely many solutions. Okay, you can have them all coinciding, like 2 lines could be the same. Well, 3 planes could all be the same. Infinite solutions. So we have 2 cases for infinite solutions. They could all be parallel, no solution. Or 2 planes are parallel, the third one intersects it, no solution. And lastly, we can have just the way they intersect. They do not intersect at the same point, no solution. Okay, so we got more options than we had before, but we only have one solution, infinite solutions, or no solution. All right. All our rules apply for a 2x2 system. You can multiply a equation by a number. You can add 2 equations together. Really, everything, all our rules are the same. So let's just take a look at an example. Make sure we can solve it. All right, so this is the one on your notes. You can do substitution or elimination. I'm going to do the first one, substitution, second one, elimination. Now, for me, 9 times out of 10, I'm doing elimination. Maybe 95 times out of 100. It's just easier for me. It doesn't mean you have to do it. I'm never going to make you choose on this one. But I'm going to show you both formats just so you can see them. So let's take a look. At substitution. Now, pick any equation. Sometimes I will number these just kind of as I'm doing my work. All right, the biggest thing with these, if you remember from last year, if you make a careless mistake, then you're screwed. And it's easy. There's a lot of stuff going on, so it's easy to make a mistake. If you add something wrong, if you forget to put down a negative, and it's hard to go back and find your mistake. So you really got to be careful. You really want to double check like before you move to the next step. And same thing with me. If I'm doing something up here and I make a mistake, please don't let me keep going. Stop me. But pick any equation and solve any equation for either variables. Some are going to be easier to solve for than the others. I'm going to take the first equation. Let's go ahead and just solve it for x. So take x plus y plus z equals 6. Get x by itself, which means I'm going to subtract y, I'm going to subtract z. Now you need to take that. That was equation number 1, you now plug this into equation 2 and 3. That's going to both of them. Okay, so I'm going to take equation 2. I'm going to take the x out. I'm going to plug it in that, 6 minus y minus z. And I'm going to take equation 3. I'm going to do the same thing. I'm just going to kind of organize my work and one on each side and move down. So for equation 2, I'm going to take 2. I'm going to take the x out. Put in 6 minus y minus z plus 3y minus z equals 11. And for equation 3, I'm going to make it 3, 6 minus y minus z minus 2y plus 3z equals 8. I'm just going to work with 2, go back to 2 and work with that and simplify it as much as I can. So go to number 2, distribute your 2, combine like terms. So distribute 2, I get 12 minus 2y minus 2z plus 3y minus z equals 11. Let's see here. Negative 2y plus 3y is y. Negative 2z minus z is minus 3z. I got a plus 12 equals 11. Subtract 12. I get y minus 3z equals negative 1. All right, did I do that right? Okay, now that's all you further can go. You're not all magically, going to get y by itself or z by itself. So our goal now is to get the other equation with a y and a z in it, and we're going to have to solve it 2 by 2. So we got that. All right, go to the second one. I get 18 minus 3y minus 3z minus 2y plus 3z equals 8. All right, but actually something really nice happens on this one. And what would that be? The z's cancel. The z's add up to 0. And that's going to be really nice here in 1 second. I get negative 3y minus 2y. I get negative 5y. The z's add up to 0. Negative 3z plus 3z. I got plus 18 equals 8. So what I can do, hold on, let me slow down, sorry. Okay, once you got that, you got negative 5y plus 18 equals 8. You can figure out what y is. Okay, and that's the whole goal. Is you want to find what the values are. So I'm going to subtract 18. And I get negative 5y equals negative 10. Divide by negative 5. And I get y equals 2. So I got that answer. Now I still got to find x and z. Where can I go with that from here? All right. Victoria, what can I do? What do you think? Yep. So we want to find the equation that just has 2 variables in it. We plug the y equals 2 in for that one. And I can figure out what z is. So I get 2 minus 3z equals negative 1. subtract 2, divide by -3, and I get z equals 1. Now go back to any, either go back to your original equations or you can go back to where we got x by itself. Doesn't matter. You can pick any one of those three, or I can go where x is by itself. It's easier if you do the x equals, what do we have? 6 minus y minus z. So plug in 2, plug in 1, and I get 3. Make sure you write this down as 3, 2, 1 in that order. All right. If it's a situation where you need to get this right, you would want to go back and double check your answers, plug them all in. Okay. Because like I said, sometimes just so it'll work out nice. If you made a mistake in there, you actually got the incorrect answer. So just be careful. All right, flip that over then. Okay, look through there. I'm going to do elimination. I want you to kind of have a mental plan of which variable you want to eliminate and how we're going to do that. All right, Christiana, what do you think? You got a variable that sticks out that might be easier?
Yeah, the ones.
All right, I would agree with that. Y. I would not mess with the, X's are not too bad because you got an X, Y. Probably wouldn't mess with the Z's. But I'm going to go for the Y's. You have got to pick two different sets of equations and eliminate the same letter. So don't eliminate the Y's from here and then say, oh, I'm going to eliminate the Z's there. That's not going to help you. It's got to be the Y from two different sets. So I'm going to use equation 1 and 2. And then I get 2x plus y minus 3z equals 7. And then I get x minus y minus 2z equals 4. All right, this one's already set up because you got a positive y and a negative y. It's automatically going to add up to 0, so that's perfect. Add those two together, and I get 3x minus 5z equals 11. Now, we are basically going to create a 2x2 system and then solve that because we know how to do that. So I have got to eliminate the same letter. Okay, do not try to eliminate the z's and then you're just going to end up getting all mixed up. So I'm going to pick equation 2 and 3. It's got to be two different ones. I'm going to put those down here. So this is equation 2. And equation 3. All right, easiest way to eliminate the y's, multiply that second equation by what? By 3. Just multiply it by 3. So I'm going to do that. And I'm just going to kind of shift it to the right here. 3 times x is 3x minus 3y. 3 times negative 2 is minus 6z equals 12. And then 3x plus 3y plus 2z equals 4. My y's cancel, which is the whole point of it. And I get 6x minus 4z equals 16. All right, now. Okay, no, nothing canceled out to leave me a single variable. I got two different variables. Now we just treat this as a whole separate problem. Okay, so find some room. This is where you really got to be organized. I'm going to move up here to the right. I'm going to take those two equations. I'm going to Figure out how to solve those. Treat these almost separate as a separate problem. So I got 3x minus 5z equals 11. I got 6x minus 4z equals 16. All right, it doesn't matter. Either eliminate the x or eliminate the z. Whichever one's going to be easier. All right, Reese, what do you got going on there? What do you think?
The X's.
And then how are you doing that? I agree.
Multiply the top one by 2.
2 or negative 2?
Negative 2.
Okay, yep. Multiply the top one by negative 2. I got enough room here. So we'll make that negative 6x plus 10z equals negative 22. That's 6x minus 4z equals 16. I got 6z equals negative 6. So I know z equals negative 1. Now go back to either of those two equations you're working with. Figure out what x is. Okay, so substitute in your negative 1. And I'm just going to pick this 6x minus 4z and make z negative 1. And I get 6x plus 4 equals 16. Subtract 4. 6x equals 12. I got x equals 2. So I got x equals 2. I got z equals negative 1. Any of your 3 original ones, substitute in, see what you get. Or y. And I'm just going to pick the top one. 2x plus y minus 3z equals 7. 2x plus y minus 3z equals 7. Make sure I copy that down right. Okay, and x is 2 plus y minus 3 times negative 1 equals 7. And I get y plus 7 equals 7. I get y equals 0. Every now and then it just throws people off. They're like, oh, that can't happen. Yeah, that's fine. You get 0 for an answer. So I get, what's my final case here? I get 2, 0, negative 1. Okay, 2, 0, negative 1. I did one by substitution. I did one by elimination. I really have no preferences for what you do. I prefer the elimination more times than not. But if you think substitution will work, go right ahead. All right, let's take a look at this third one. We're not going to get to that bottom one today. We're going to have to save that one. But take a look at this one, how it's just a little bit different. Look through it. Look through it. See if you can come up with an idea. Or first of all, identify how it's a little bit different than the last one, last couple. All right, it's a little bit different. There are only 2 variables in each equation, but there's never the same 2 variables. There's 3 variables total. There's an x, there's a y, and there's a z, but no 2 equations have the same 2. First one has x and a y. Second one has a y and a z. Third one has an x and a z. All right, any ideas? What we can do to kind of solve, to kind of go from here. All right, Paige, you got any ideas?
I don't know.
Not sure? All right. Okay. So right now we're stuck. Somehow stuck. Sometimes you just want to try something. See if you can pick any 2 equations and just eliminate a variable. and kind of see what happens from there. So if I take equation 1 and equation 2, they both have what letter? Both have a y. Let's get rid of the y. I'm going to eliminate the y there. Now I'm going to kind of rewrite this. So equation 1, and I'm going to kind of put a space where it's missing the variable. So I'm going to write this as x plus y. And I'm going to just leave a spot for the z, even though it's not there. And then the second one is going to be 2y plus 3z equals 7. So I'm going to eliminate the y by multiplying the first one by -2. And that gives me -2x minus 2y. And I'm just going to put down plus 0z equals -18. Okay. You can use that as like a placeholder. Just leave it as a placeholder. The second one, I'm going to put a 0x plus 2y plus 3z equals 7. And now if you combine everything, I'm going to have -2x. The y's cancel. I get plus 3z, and I get -11. All right, now it's not like I got a variable, like I didn't solve for anything, but I got it down to there. So I want you to take a look. Why is that helpful? Okay, see if you can figure out why is that helpful. I got rid of the y's, but I'm nowhere near done. But I am closer. Carissa, you got why it's helpful? Not sure? All right. Hope? Yeah, take a look at that third equation. And this is what you want to do. You just need to come up with 2 different equations that have the same 2 sets of variables. That's it. Okay? So now I got -2x plus 3z equals -11. And I got equation 3 has an x and a z. I can solve those now. That's a system of equations. So somehow just eliminate a variable and kind of create another equation that has the same variables as one of your original ones. And so I'm just going to write equation 3. What is it? X minus 2z equals 4. And now I'm going to solve this. I'm going to multiply the bottom equation by +2. Go ahead. From there, you should be able to kind of keep rolling and finish it out. And so if I multiply that by 2, let me put it in red. I get -2x plus 3z equals -11. I got 2x minus 4z equals 8. The x's cancel. I end up with -z equals -3. Z equals +3. Is that right, Christian? Okay, so I get z equals 3. Now, plug into either one of these 2 equations. I'm just going to go x minus 2z equals 4. X minus 2 times 3 equals 4. X minus 6 equals 4. Add 6, I get x equals 10. Now go back to any original equations, find something that has a y in it, replace it, either the x or the z. Which one has a y? Is the first one? X plus y equals 9. So I got x plus y equals 9. X is 10. When I subtract 10, I get -1. So I got, what do I got here? 10, -1, 3. 10, -1, 3. Okay, for that one. All right, we're going to skip that next one because I know I won't get as far in probably some of the other classes. So I'm going to save that. All right, you got 3 problems. These are out of the book, but I put them up here so you didn't have to go to your text, e-text. Try to organize as best you can. I don't care how you solve them. Okay? But see if you can get done with at least, well, I'll let you get done with all 3 of them because you guys are going to have a little bit extra time. But at least 2 of them. If you get stuck, let me see you. A lot of ways you can make just little errors. And I want you guys to stay in here because these things touched up.